Hello guys, this is the MEPtutor, and in today's video I'll be solving this problem. We have this vectorial function here, r, and we have to find its normal and binormal vector. We know that the normal vector of a function, of a vectorial function, is the first derivative of the tangent vector divided by the modulo of the first derivative of the tangent vector. So we need to find the tangent vector. And the tangent vector is equal to the first derivative of the vectorial function divided by the modulo of the first derivative of the vectorial function. So we need to find the first derivative of the vectorial function. So let's do that first. Let's grab red. The first derivative is we need to derive all the components of the vectorial function. So this will be equal to 1. This will be 3 cosine of t. I won't write the argument of the trigonometric function to don't waste space. And we got here minus 3 times sine of t. So then we need to find the modulo of this first derivative, which is this. The square root of each of the components is squared. We got 1 squared is 1. Here we got plus 9 times cosine squared plus 9 sine squared. Okay, here we can extract a common factor of 9 and we can use the fundamental identity of the trigonometry. We know that cosine squared of something plus sine squared of something, the same thing, is equal to 1. So after extracting the common factor of 9, the other side will be cosine squared plus sine squared, which is 1. So it will be 9 times 1. So our module, let's grab red again, it's basically equal to the square root of 10. 1 plus 9. Okay, so we have this, we have the first derivative and the module of the first derivative. We can get the tangent vector. Okay, the tangent vector, we know the formula here, so let's do that. We got 1 divided by the square root of 10 plus, okay, we got 3 divided by the square root of 10 times cosine minus 3 sine divided by the square root of 10. So we have our tangent vector. So to find the normal vector, we need to derive the tangent vector. So let's do this. The first derivative of our tangent vector will be equal to 0. Then we will have minus 3 divided by the square root of 10 times sine. And here we will have minus 3 cosine divided by the square root of 10. Okay, this is our first derivative of the tangent vector. So we need then the modulo of the tangent of the first derivative of the tangent vector. So let's find that. Let's grab red again. Okay, the modulo of this will be equal to the square root of everything squared. We got 9, we got 0 squared, which is 0. And here we got 9 divided by 10 sine plus 9 divided by 10 plus cosine. Okay, s squared, both are squared. So we can use exactly the same trick as in the previous example. This and this will be equal to 1 after we extract the common factor of 9 divided by 10. So this is 9 divided by 10 times 1. and this is the square root of the numerator is 3, and then the denominator we got the square root of 10. This is our module. Having the tangent prime and the module of it, we can find the normal vector. Okay, the normal vector will basically equal to 0 all of this minus 3 divided by the square root of 10 sine, here minus 3 cosine divided by the square root of 10 divided by 3 divided by square root of 10. So this is 0, and here we can simplify the term. So we have that the normal vector will be equal to 0 minus sine and minus cosine. Okay, that's awesome. It's not that big. So we got the normal vector, so we have to find the binormal vector. If imagine our vectorial function is a curve, something like this, whatever, the tangent vector will be, at this point, will be a tangent here. The normal vector will be something like this. And how will be the binormal vector? It will be if we are from the up, it will look like a point. But if we put some perspective, we can put it something like this. And it will be a vector that is perpendicular to both the normal and the tangent vector. Something like this, okay? Yeah. And how do we find the normal vector? Red, now black again. We do the cross product of the tangent vector cross product normal vector. So the binormal vector will be the tangent vector cross product the normal vector. So we have construct the matrix here. We got the unit vectors I, J, K, triball. We got the tangent vector, which is 0 minus 3 sine divided by the square root of 10. And we got minus 3 cosine divided by the square root of 10. And we have the normal vector. Oh, I wrote this. I was writing the prime. It's not the prime, it's the tangent vector. It's this one. Sorry. This is not 0. This is 1 divided by the square root of 10. And this is positive, and this is negative. And it's not sine here. Here is cosine, and here is sine. Oh my god, I was messing up. Here's the cosine. And here is the sine. And we put the normal vector here. The normal vector will be 0 minus sine and minus cosine. So we find the determinant of this matrix, and we got our binormal vector. On I, we will have minus 3 divided by the square root of 10 of cosine squared minus 3 divided by the square root of 10 times sine squared. This is I. On J, what we have on J, here we got 0, and on the other direction we got cosine divided by the square root of 10. This will be J. And K, here we got C, here we 0, 0, and on the right direction we got minus sine divided by the square root of 10. This is k. And we put the I here. We do the same trick that we did at the beginning of the exercise. That cosine squared plus sine squared is 1. We extract this common factor of minus 3 divided by the square root of 10 times 1. So I will be minus 3 divided by the square root of 10. This is I. So we have our 3 vectors. And this is equal to the binormal vector. We have the binormal vector, and we have our normal vector here. This is the binormal vector. This is the normal vector. This is the whole problem.